Hey everyone, welcome to The Explainer. I am super excited to dive into this with you today. Have you ever actually stopped to wonder how your phone's weather app just instantly knows to tell you it's raining in London? Or, how your company's checkout page seamlessly connects with your bank? Well, we live in this highly connected digital world where thousands of completely different software systems need to talk to each other, literally every single second. But here's the catch. They're built by entirely different people using entirely different coding languages. So how do they actually communicate without the whole thing just breaking down? The answer is APIs. And today, we are going to demystify exactly what they are, how they work, and why, especially if you're a manager or a business leader, you absolutely need to understand them.
Okay, let's take a quick look at our menu for today. We're going to cover 1. Meet your digital waiter, 2. API access levels, 3. Fun APIs in the wild, 4. Testing and status codes, and finally 5. Keeping your data safe. Let's get into it.
Section 1. Meet your digital waiter. To really wrap our heads around these technical concepts and ground them in something familiar, I want you to just imagine your absolute favorite restaurant or cafe. Think about the incredible smells, that bustling kitchen in the back, and you sitting down at your table, totally ready to order.
So, API stands for Application Programming Interface. But let's put that in plain English, right? It's basically a set of rules that acts as a bridge or a middleman, allowing two completely different software systems to communicate. It's quite literally a contract of service between two applications. It acts as this common language that lets them exchange data without needing to know a single thing about how the other application was actually built under the hood. Let's apply our restaurant metaphor here to really understand the architecture. In the software world, we have what's called a client and a server. The client is you, the customer sitting at the table with a menu. You know exactly what you want. The server is the kitchen in the back. They've got all the ingredients, the databases, the ability to cook up whatever you need. But you don't just march into the kitchen and start grabbing ingredients yourself, right? No way. You need a waiter. Well, the API is your digital waiter. It takes your request, runs to the kitchen, tells them exactly what you need, and then brings the finished dish right back to your table. Okay, let's actually trace the exact life cycle of how this waiter works step by step. First, the client sends a request, specifically an HTTP request. Think of this as you giving your order to the waiter. You might say, "Get me a steak," or "Post a new reservation." Second, the API, our waiter, authenticates the request to make absolutely sure you're a paying customer, and then it translates that order for the kitchen. Third, the server, or the kitchen, processes the order, pulling the right data from the database. And finally, the API delivers the response back to you. Now, this is usually packaged up in a format called JSON. You can basically think of JSON as the universal digital Tupperware that holds your data neatly so your app can read it perfectly.
Moving right along to Section 2, API access levels. Because here's the thing about our restaurant. Not everyone gets the exact same menu. Let's look at how businesses strategically share their data. There are basically 3 main access levels for APIs that dictate your overall business strategy. First up, public APIs. Think of this as your standard front-of-house menu. Anyone can walk in off the street and use it. Companies use these to encourage external developers to build apps around their services. Second, we have partner APIs. Now, this is the secret menu for VIPs. You only share this with authorized external business partners so you can integrate your system seamlessly. And finally, private APIs. This is the internal kitchen shorthand. It's for your developers only, allowing something like your company's internal HR system to talk to your payroll system, completely hidden from the outside world. As a manager, knowing which API access level to use is just absolutely crucial for protecting your digital assets while still expanding your business reach.
All right, Section 3, Fun APIs in the wild. Let's step out of the restaurant for a second and look at how this works on the open web. It really brilliantly illustrates the sheer variety of data we can access these days. There are some genuinely amazing, free, public APIs curated on places like GitHub right now. You've got heavy hitters like OpenWeatherMap, which developers pull into web apps to show you real-time forecasts. But, it's not all strictly serious business. There are APIs for absolutely everything. Want your new app to randomly display interesting trivia about felines? Boom, just connect to the Cat Facts API. More of a dog person? No problem, there's a Dog Facts API too. Because these are public APIs. Literally, any developer can write a few lines of code, make an HTTP request, and instantly have this data flowing right into their application. Section 4, Testing and Status Codes. Now, how do we actually know the food coming out of the kitchen is any good? In the restaurant world, a manager tastes the dish before it ever hits the dining room floor. In software, we need quality control for our APIs too. Before an API is ever exposed to real users, developers go through really rigorous integration testing. They use specialized tools, like one very popular one called Postman, to basically simulate being a customer. They send requests to the API to validate its functionality, check if it's reliable under really heavy traffic, measure its performance speed, and of course, probe its security. They are essentially making sure our waiter doesn't trip and drop the food on the way to the table. Now, when developers test these APIs, the server responds with status codes. This is a quick shorthand to say how things went. If you get a 200, it is time to celebrate. 200 means okay. The waiter successfully took your order, the kitchen cooked it flawlessly, and your data was delivered. Perfect execution. But what if you get a 404? We've all seen this one while browsing the web, right? 404 means not found. Back to our restaurant analogy. This is the waiter returning to your table empty-handed, apologizing profusely because you ordered the clam chowder, but sadly, they are completely out of soup. The API endpoint you asked for, it just doesn't exist. And then there's the dreaded 500. A 500 status code means internal server error. And trust me, this is not a problem with what you ordered. This means there is literally a fire in the kitchen. The server crashed or the database failed, and the API simply cannot fulfill the request. As a manager, you definitely want monitoring tools in place to alert your team the absolute second a 500 error pops up. Which brings us to Section 5, keeping your data safe. This is our final and undeniably most critical section. APIs are incredibly powerful, but you know the saying that power comes with responsibility. We have to keep the restaurant and our data safe. We've kind of assumed so far that anyone who sits at the table gets served. But what if you are running a highly exclusive private club? You need to ask, who is actually allowed to place an order in the first place? We need a bouncer at the front door. And in API terms, that bouncer is authentication. Let's break down exactly how this bouncer checks IDs. First off, we have API keys. An API key identifies the application making the call. It verifies the program itself has access rights. But API keys aren't enough for individual users. For that, we use authentication tokens, which verify that the user is exactly who they claim to be. Kind of like when you log into your secure bank app. Implementing strong authentication prevents nasty automated attacks, like credential stuffing, where hackers use stolen passwords from other sites to try and just brute force their way into your API endpoints. If you look at data from the OWASP API Security Top 10, which is basically the gold standard for web security, it lists broken user authentication as an incredibly prevalent and highly exploitable risk. If your developers misconfigure the authentication mechanism, say maybe they allow weak passwords, or worse, they put sensitive tokens right there in the web URL, attackers can effortlessly hijack the waiter. They can assume other users' identities, read personal data, and perform highly sensitive actions on their behalf. It is truly a manager's worst nightmare.
And here is another major pitfall identified by OWASP: excessive data exposure. Sometimes, developers get a little lazy. Instead of telling the kitchen to prepare exactly what the customer ordered, they just have the kitchen wheel out the entire contents of the refrigerator, and they rely on the customer to only eat what they ordered. In API terms, they send a massive packet of data, including highly sensitive personally identifiable information, and they just rely on the client-side app to hide it from the screen. But hackers can easily intercept that traffic. You must never rely on the client side to filter sensitive data. Your API should only ever return the precise data needed.
I really want to emphasize this quote from OWASP for a second. Unauthorized access can result in data disclosure to unauthorized parties, data loss, or data manipulation. This isn't just an IT problem, folks. This is a massive business impact problem. If your APIs aren't secure, your entire company is vulnerable. So as we wrap up this explainer today, I want to leave you with one final vital thought. APIs are the incredible digital waiters that make our entire modern software world possible, but they are also the front door to your business data. My question to you is, are you absolutely certain who holds the keys? I highly recommend you go talk to your engineering team today. Ask them about their API strategy, their testing protocols with tools like Postman, and exactly how they handle authentication. Thank you so much for joining me today. And as always, keep learning.